Arithmetic and logic unit. When a program runs on a computer, the part of the computer that carries out the instructions is called the arithmetic and logic unit. Instruction. At each step of its operation, the input to a central processing unit is an instruction. RAM, random access memory, is called that because you can pick any two random locations and it will take the same time to access the data. Address. A byte in memory is identified by a unique number called its address. A byte consists of 8 bits. Argument. In Java, an argument is information provided to a method. IPO. Input into memory, process the computation, output the result. Memory. A way to store entered values and calculated results. Algorithm. An ordered set of steps to solve a problem that should be written in pseudocode. Pseudocode. A written plan between English and formal code. Syntax. A set of rules that defines how to construct valid statements in a given language. A symbolic representation. Semantics. Describes the logical entities of a program. Most compilers are unable to catch semantic errors, although Java catches some, such as type conversion. Variable. A named storage location in a computer's RAM. A box that holds data. Abstraction. Used to make simple what is complex, deferring certain details to focus on higher-level problems. Behaviors. What objects do? The behavior of a car includes change gear, go faster, slower, go in reverse, stop, shut off. Procedure. A set of programming statements that, together, perform a specific task. Control flow mechanisms. Statements in Java are read from top to bottom. Control flow statements break up the flow of execution by employing decision-making, looping, and branching, enabling your program to conditionally execute particular blocks of code. Trace. Tracing is monitoring the value of a variable while a loop is being executed. For example, if you have a loop that reduces the value of x by 1, and if the initial value of x is 5, then you're tracing the value of x from 5 to 4 to 3 to 2 and to 1. Data type specifies the size and type of values that can be stored in an identifier. Data types in Java are classified into 2 types: primitive, which includes integer, character, boolean, and floating point; non-primitive, which includes classes, interfaces, and arrays; block, a group of one or more statements enclosed in braces. Compile time. An error in a program that involves a violation of language rules will be detected at compile time. Algorithm. An ordered set of steps to solve a problem that should be written in pseudocode. Application versus applet. All Java programs are classified as applications and applets. While applications are standalone Java programs that run directly on your machine, applets are specific programs that require the use of a browser, and should be included in an HTML web document. Application programs run with the help of a virtual machine independent of any security restrictions, whereas an applet cannot run without the help of a browser, and is subjected to more harsh security restrictions in terms of network access. Applets do not require any sort of deployment procedure or installation. Programming language. A programming language is a set of commands, instructions, and other syntax used to create a software program. Languages that programmers use to write code are called high-level languages. This code can be compiled into a low-level language, which is recognized directly by the computer hardware. High-level languages are designed to be easy to read and understand. This allows programmers to write source code in a natural fashion, using logical words and symbols. For example, reserved words like function, while, if, and else are used in most major programming languages. Symbols like less than, greater than, equals, and equals are common operators. Many high-level languages are similar enough that programmers can easily understand source code written in multiple languages. Examples of high-level languages include C++, Java, Perl, and PHP. Languages like C++ and Java are called compiled languages, since the source code must first be compiled in order to run. Languages like Perl and PHP are called interpreted languages, since the source code can be run through an interpreter without being compiled. Generally, compiled languages are used to create software applications, while interpreted languages are used for running scripts, such as those used to generate content for dynamic websites. Low-level languages include assembly and machine languages. An assembly language contains a list of basic instructions and is much more difficult to read than a high-level language. In rare cases, a programmer may decide to code a basic program in an assembly language to ensure it operates as efficiently as possible. An assembler can be used to translate the assembly code into machine code. The machine code, or machine language, contains a series of binary codes that are understood directly by a computer CPU. Needless to say, machine language is not designed to be human-readable. Machine language, machine code, also called machine language, is a computer language that is directly understandable by a computer CPU. And it is the language into which all programs must be converted before they can be run. Each CPU type has its own machine language, although they are basically fairly similar. After the source code for a program has been written by one or more humans in a programming language, e.g., C or C++, it is compiled, i.e. converted, into machine code by a specialized program called a compiler, or by an assembler in the case of assembly language. This machine code is then stored as an executable file, i.e. a ready-to-run program, and can be executed, i.e. runs by the operating system anytime it is instructed to do so by another program or by a user. Machine code is extremely difficult for humans to read because it consists merely of patterns of bits, i.e. zeros and ones. Thus, programmers who want to work at the machine code level instead usually use assembly language, which is a human-readable notation for the machine language in which the instructions represented by patterns of zeros and ones are replaced with alphanumeric symbols, called mnemonics, in order to make it easier to remember and work with them, including reducing the chances of making errors. In contrast to high-level languages, e.g., C, C++, Java, Perl and Python, there is a nearly one-to-one correspondence between a simple assembly language and its corresponding machine language. Assembly language. An assembly language is the most basic programming language available for any processor. With assembly language, a programmer works only with operations that are implemented directly on the physical CPU. Assembly languages generally lack high-level conveniences such as variables and functions, and they are not portable between various families of processors. This language is still useful for programmers when speed is necessary or when they need to carry out an operation that is not possible in high-level languages. High-level languages. A high-level language is a programming language designed to simplify computer programming. It is high-level since it is several steps removed from the actual code run on a computer's processor. High-level source code contains easy-to-read syntax that is later converted into a low-level language which can be recognized and run by a specific CPU. Examples include C++, C#, COBOL, Fortran, Java, JavaScript, Objective-C, Pascal, Perl, PHP, Python, Swift. Keywords or reserved words, or words that have a special meaning in programming language such as public and class. Operators, operands, are symbols or words that perform operations on one or more operands. Usually an item of data, such as number. Encapsulation is one of the four fundamental object-oriented programming concepts including inheritance, polymorphism, and abstraction. Encapsulation is a method of wrapping the variables and code acting on the methods together as a single unit. In encapsulation, the variables of a class will be hidden from other classes and can be accessed only through the methods of their current class. Therefore it is also known as data hiding. To achieve encapsulation you must first declare the variable of a class as private. Then provide public setter and getter methods to modify and view the variable's values. The benefits of encapsulation is that the fields of a class can be made read-only or write-only. A class can have total control over what is stored in its fields. Identifier. Identifiers are the names of variables, methods, classes, packages and interfaces. Unlike literals, they are not the things themselves, just ways of referring to them. In the Hello World program, Hello World, string, args, main and println identifiers. Identifiers must be composed of letters, numbers, the underscore and the $. Identifiers may only begin with a letter, the underscore, or a dollar sign. Line versus statement. A line is simply a line in the body of a program. A statement is a complete instruction that causes the computer to perform some action. Byte. In most computer systems, a byte is a unit of data that is 8 binary digits long. A byte is the unit most computers use to represent a character such as a letter, number, or typographic symbol. Each byte can hold a string of bits that need to be used in a larger unit for application purposes. Java Virtual Machine (JVM), a program that reads Java bytecode instructions and executes them as they are read. An interpreter. A Java Virtual Machine (JVM) is a virtual machine that enables a computer to run Java programs as well as programs written in other languages that are also compiled to Java bytecode. The JVM is detailed by a specification that formally describes what is required in a JVM implementation. Having a specification ensures interoperability of Java programs across different implementations so that program authors using the Java Development Kit (JDK) need not worry about idiosyncrasies of the underlying hardware platform. The JVM reference implementation is developed by the OpenJDK project as open source code and includes a JIT compiler called Hotspot. The commercially supported Java releases available from Oracle Corporation are based on the OpenJDK runtime. Eclipse OpenJ9 is another open-source JVM for OpenJDK. The Java Virtual Machine is an abstract, virtual computer defined by a specification. The garbage collection algorithm used in any internal optimization of the Java Virtual Machine instructions, their translation into machine code, are not specified. The main reason for this omission is to not unnecessarily constrain implementers. Any Java application can be run only inside some concrete implementation of the abstract specification of the Java Virtual Machine. One of the organizational units of JVM bytecode is a class. A class loader implementation must be able to recognize and load anything that conforms to the Java class file format. Any implementation is free to recognize other binary forms besides class files, but it must recognize class files. The class loader performs 3 basic activities in this strict order. 1. Loading, finds and imports the binary data for a type. 2. Linking, performs verification, preparation, and, optionally, resolution. Verification ensures the correctness of the imported type. Preparation allocates memory for class variables and initializing the memory to default values. Resolution transforms symbolic references from the type into direct reference. 3. Initialization invokes Java code that initializes class variables to their proper starting values. In general, there are 2 types of class loader: bootstrap class loader and user-defined class loader. Every Java Virtual Machine implementation must have a bootstrap class loader, capable of loading trusted classes. The Java Virtual Machine specification doesn't specify how a class loader should locate classes. Portable. A program is portable if it can be written on one type of computer and run on many types of computers with little or no modifications. Class. A class, in the context of Java, are templates that are used to create objects, and to define objects' data types and methods. Call properties include the data types and methods that may be used by the object. All class objects should have the basic class properties. Classes are categories, and objects are items within each category. Java class libraries, aka API. A class declaration is made up of the following parts. 1. Modifiers. 2. Class name. 3. Keywords. 4. Class body within curly brackets. This may be explained with a hypothetical example of a tree and types of trees. Generally, a tree should have branches, stems and leaves. Thus, if banyan is a tree, banyan should have all of the characteristics of a tree, such as branches, stems and leaves. It is impossible to say that a pigeon is a tree, because the pigeon does not have branches, stems and leaves. Similarly, basic Java object properties are defined within that object's corresponding class. Source code, the programming statements written by the programmer. The source code is run through a compiler to turn it into machine code, also called object code, that a computer can understand and execute. Object code consists primarily of ones and zeros, so it isn't human-readable. Programming languages that compile their code include C, C++, Delphi, Swift, Fortran, Haskell, Pascal and many others. Compiler translates source code into an executable format. The most common form of output from a Java compiler is Java class files containing platform-neutral Java bytecode. But there are also compilers that output optimized native machine code for a particular hardware operating system combination. Most Java to bytecode compilers, JAX being a well-known exception, do virtually no optimization, leaving this until runtime to be done by the JRE citation needed. The Java virtual machine loads the class files and either interprets the bytecode or just-in-time compiles it to machine code and then possibly optimizes it using dynamic compilation. Bytecode, Java bytecode, is the result of the compilation of a Java program, an intermediate representation of that program which is machine-independent. The Java bytecode gets processed by the Java virtual machine (JVM) instead of the processor. It is the job of the JVM to make the necessary resource calls to the processor in order to run the bytecode. Java bytecode is the resulting compiled object code of a Java program. This bytecode can be run in any platform which has a Java installation in it. This machine independence is because of the Java virtual machine that runs the bytecode in proxy of the processor, which means that a Java programmer does not have to be knowledgeable about the quirks and nuances about specific operating systems and processes that the program will be run on, because the virtual machine takes care of those specifics. The Java bytecode is not completely compiled, but rather just an intermediate code sitting in the middle, because it still has to be interpreted and executed by the JVM installed on the specific platforms such as Windows, Mac or Linux. Upon compile, the Java source code is converted into class bytecode. Syntax errors. Java syntax errors refer to mistakes made by a programmer in implementing the grammar of the Java programming language. It doesn't cover mistakes in logic of the program itself. Logic error, bug, a logic error, or logical error, is a mistake in a program's source code that results in incorrect or unexpected behavior. It is a type of runtime error that may simply produce the wrong output or may cause a program to crash while running. Many different types of programming mistakes can cause logic errors. For example, assigning a value to the wrong variable may cause a series of unexpected program errors. Multiplying two numbers instead of adding them together may also produce unwanted results. Even small typos that do not produce syntax errors may cause logic errors. Debugging. Debugging is the routine process of locating and removing computer program bugs, errors or abnormalities, which is methodically handled by software programmers via debugging tools. Debugging checks, detects and corrects errors or bugs to allow proper program operation according to set specifications. Developing software programs undergo heavy testing, updating, troubleshooting and maintenance. Normally, software contains errors and bugs, which are routinely removed. In the debugging process, complete software programs are regularly compiled and executed to identify and rectify issues. Large software programs, which contain millions of source code lines, are divided into small components. For efficiency, each component is debugged separately at first, followed by the program as a whole. Coding conventions. The Java code conventions are defined by Oracle in the Coding Conventions document. In short, these conventions ask the user to use camel case when defining classes, methods, or variables. Classes start with a capital letter and should be nouns. For methods, the names should be verbs in imperative form, like get break system type, and should start with a lowercase letter. One example from the coding conventions is how to define a constant. Constants should be written with capital letters in Java, where the words are separated by an underscore character. In the Java coding conventions, a constant is a static final field in a class. Operating system. An operating system, OS, in its most general sense, is software that allows a user to run other applications on a computing device. While it is possible for a software application to interface directly with hardware, the vast majority of applications are written for an OS. which allows them to take advantage of common libraries and not worry about specific hardware details.